All right, so in this video, we're going to look at graphs and functions. And so there's not a ton of notes for me to give you. We're just going to go straight into the examples. Okay, so if you have trouble with domain and range, interval notation, please go back and look at the previous videos. All right, so example 1 says state the domain and range of each graph, use interval notation. Okay, so the graph is already provided for you. F of x is equal to the square root of x squared minus 4. And the domain, right, if you remember, is a set of all input values for which a function is defined. In other words, what is allowed into the function, right? What x values are allowed into the function. Well, instead of analyzing it algebraically, the graph is provided for us. So I would look at on your x-axis, going from left to right on the x-axis, and the smallest y value, of course, it just keeps on going forever, right? So if it keeps on going forever, I'm going to go from left to right. I'm going to say minus infinity until it reaches the value of -2, bracket, right? Because it stops at -2 and includes the value of -2. There's nothing in between -2 and 2, right, on this graph. Union mark, right? +2, and then goes all the way to positive infinity. And that will be the domain, okay? So parentheses and brackets matter. If you don't write it correctly on a quiz or test, of course, that's wrong. Now, the range is a set of output values or y values, right? The smallest y value on this graph, if you look at it, right, is where the x-intercept is. The smallest y value is just 0. So the range is from 0 to positive infinity. All right, moving on. Now, this one, I didn't quite give you any numbers, okay? So I suppose you could use Desmos, but again, just recall that this is in vertex form, right? The vertex is h comma k. It's just -2 comma 3, okay? So now, once we know this coordinate, we can state the domain, right? The domain, or I should say we could state the range. The domain, right, the x value is not restricted. It can be any x value in the number line. So it's going to be all real, which we say is minus infinity to infinity. And the range, right, for the lowest y value, right, the y value can go really, 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 really low, right, because the arrows are dipping down. So going from bottom to top, it's minus infinity until it hits the y value of the vertex, which is 3, and that's your range. All right, so moving on to example number 2. It says for f of x below, state the domain and range, find the x values for which f of x is equal to 0, and then find f of 0. Okay, so they give you the piecewise function, and they give you the graph over here. I did not give these values on purpose because I want you to be able to interpret it because they give you a piecewise. So I'm going to answer these questions a little bit out of order. But let's just take a look, right? If we're asked to state the domain of this function, right, it looks like your x can be anything, right? So the domain is going to be all real. Now the range, right, is going to be from minus infinity until it reaches this point. And so the question mark is I need to know what that point is, right? And that's where part C is quite useful. So this is what I mean by doing it out of order. Part C asks us to find f of 0. And f of 0, right, 0 is defined for this top part of the function, right, because 0 is less than or equal to 0 in the piecewise. So you plug it into the top part, this guy right here, right, because 0 is less than or equal to 0. So f of 0 is equal to 0 plus 4, and now you know that value is 0 comma 4. Okay, so in other words, that's your y-intercept. So f of 0 is 4. That's going to help us answer part A, right? The range is from minus infinity to positive 4, and close that with a bracket. All right, part B asks us to find x values for which f of x is equal to 0, right? Basically, this is asking you to find, right? If this is the y value, which is 0, it's basically asking you to find the x-intercepts. Okay, find the x-intercepts. All right, now, of course, if you graph this on Desmos, you can just scroll over and find it, but we're going to do this by hand, right? The way you find the x-intercepts is you set f of x is equal to 0. So in our piecewise function, we're going to have two values. We're going to have 0 is equal to x plus 4, right? We're going to have two equations, I should say. 0 is equal to 4 minus x squared. So in other words, what are these x coordinates right here? That's what we're trying to find, right? Question mark, question mark. Okay, one-step equation. Over here, you're going to get x is equal to negative 4. That must be this coordinate. Okay. And if you solve this equation, right, you're going to get x squared is equal to 4, but when you take the square root of both sides, you're going to get x is equal to plus 2 or x is equal to negative 2. So the question is, which one is it going to be? Now, remember, for this equation right here, right, it's defined for x is greater than 0. So we're not going to use this guy right here, right? X has to equal positive 2. So this coordinate right here has to be positive 2. So the answer, part B, is x is equal to negative 4 and 2. Okay, so that's how you interpret the graph using the piecewise function, even if the numbers aren't provided. And that will conclude this video.